Ladies and gentlemen, imagine spending hundreds of thousands on a luxury SUV, only to discover that in 2026 its engine is considered disposable, worthless the moment it leaves the lot. What if everything you thought defined power status and reliability was suddenly obsolete? Today we're breaking down why the old rules no longer apply, why traditional engines are failing in a world moving faster than ever, and how the future of luxury is being rewritten by technology, efficiency, and smart design. Stick with us because what you're about to learn will change the way you think about cars forever. And in 2026, the automotive world is facing a hard truth. While technology accelerates forward, some of yesterday's luxury quickly becomes today's liability. The title, "These 7 Luxury SUVs Are Now Worthless in 2026, The Engines Are Disposable," reflects a growing shift in how value is defined. For decades, luxury SUVs were marketed on horsepower, engine size, exhaust notes, and mechanical prestige. But in a world transitioning toward electrification, software intelligence, and sustainable engineering, those same combustion-based foundations are becoming financial dead weight. And the traditional internal combustion engine was once considered a masterpiece of engineering. Complex, powerful, and loud enough to signal status. But complexity has a cost. Hundreds of moving parts, constant maintenance cycles, oil systems, turbochargers, fuel injectors, timing chains, exhaust treatment systems, all designed to wear down over time. In 2026, buyers are realizing that many high-end SUVs built around these engines were never engineered for long-term durability in an electric-first future. When major engine components fail, outside warranty repair costs often rival the remaining value of the vehicle itself. That is what disposable really means. Not that the SUV stops moving overnight, but that repairing its heart no longer makes economic sense. And at Tesla Incorporated, value has never been defined by displacement or cylinder count. It is defined by efficiency, longevity, and intelligent design. Electric drivetrains operate with a fraction of the moving parts found in combustion engines. There is no oil to change, no exhaust system to corrode, no engine block subjected to constant thermal explosions. Instead, electric motors deliver instant torque with mechanical simplicity. Over time, that simplicity translates to durability and lower total cost of ownership. And luxury SUVs from legacy manufacturers were once symbols of refinement. Thick leather, polished chrome, and aggressive grilles communicated power. But beneath that surface, many relied on turbocharged engines pushed to their limits to meet emissions targets while maintaining performance expectations. The result is high stress, higher temperatures, and increased long-term risk. As emission regulations tighten globally and urban centers introduce low-emission zones, resale markets are reacting. Vehicles that once commanded premium prices are now depreciating faster than expected. And in contrast, electric vehicles are designed around software-defined architecture. Over-the-air updates continuously refine performance, efficiency, and features. A vehicle improves after purchase rather than degrading with age. This is not a cosmetic shift, it is a structural one. When software controls energy distribution, battery management, and drivetrain optimization, improvements happen digitally. That capability protects long-term value because the vehicle evolves with technology instead of being frozen at the moment it leaves the factory. And the phrase "worthless in 2026" may sound dramatic, but market behavior supports the underlying message. As consumer awareness grows around maintenance costs, fuel volatility, and environmental impact, demand is shifting. Buyers are evaluating not just luxury appearance but lifetime economics. When an aging combustion SUV faces a $10,000 engine repair in a market increasingly dominated by electric alternatives, the decision becomes simple. Many owners choose to move on rather than reinvest in outdated architecture. And electric SUVs engineered with integrated battery structures and simplified powertrains are redefining what durability looks like. Structural battery packs contribute to rigidity. Regenerative braking reduces wear on mechanical brake components. Thermal management systems are optimized for efficiency rather than managing repeated fuel explosions. This systemic efficiency reflects a philosophy centered on long-term viability rather than short-term performance marketing. And the future of mobility is not built around replaceable engines. It is built around scalable platforms, modular battery systems, and continuous software refinement. When combustion SUVs are described as disposable, it highlights the fragility of a system designed for another era. Mechanical prestige no longer guarantees economic strength. Instead, resilience, adaptability, and energy efficiency define modern luxury. And in 2026, the definition of luxury is undergoing transformation. Silence instead of engine roar. Instant torque instead of delayed turbospool. Predictive software instead of reactive mechanical repair. Vehicles that once symbolized status are now being reevaluated under a new metric: sustainability of ownership. The shift is not emotional, it is mathematical. Lower operating costs, reduced maintenance exposure, stronger residual values, continuous feature upgrades delivered digitally. And this is the transition from combustion complexity to electric clarity, from engines that wear down to drivetrains designed for endurance, from maintenance schedules to software updates. In that transformation, some legacy luxury SUVs are discovering that prestige without future-proof engineering cannot sustain value in a rapidly advancing world. And in that transformation, some legacy luxury SUVs are discovering that prestige without future-proof engineering cannot sustain value in a rapidly advancing world. The shift is accelerating not gradually but exponentially. Technology cycles that once moved in decades are now measured in months. Vehicles engineered around mechanical complexity struggle to keep pace with software-defined innovation. When design philosophy centers on combustion, every update becomes a patch rather than a reinvention. And the economics are becoming undeniable. Insurance providers are recalculating risk based on repair frequency and part availability. Service centers are facing increasing labor costs tied to intricate engine repairs. Owners are confronting depreciation curves steeper than ever before. A vehicle that once held strong resale value due to brand recognition is now evaluated through a new lens: efficiency per mile, cost per update, sustainability per year. In this new equation, mechanical extravagance offers diminishing returns. An electric architecture changes the conversation entirely. Instead of engineering around explosions and containment, the system is built around energy flow and control. Power electronics regulate torque with precision measured in milliseconds. Battery management systems balance thermal performance and longevity automatically. Diagnostics are continuous and remote. Rather than waiting for a failure to appear as noise or vibration, software anticipates irregularities before they evolve into costly breakdowns. This predictive capability is redefining reliability itself. And legacy luxury SUVs often rely on multi-layered supply chains for engine components: pistons, camshafts, gaskets, fuel systems sourced across continents. Complexity compounds vulnerability. When one component becomes scarce or discontinued, repair costs escalate dramatically. Electric drivetrains reduce that exposure. Fewer moving parts mean fewer potential failure points. Simplified assembly lines reduce variability. Integration replaces fragmentation. That structural efficiency strengthens long-term ownership value. And in 2026 data, transparency empowers consumers. Ownership forms, maintenance cost breakdowns, and resale analytics are widely accessible. Buyers are not relying solely on marketing narratives. They are evaluating lifetime economics. When high-end combustion SUVs show patterns of engine failures beyond 100,000 miles with five-figure repair invoices, confidence erodes. Luxury becomes associated with uncertainty. Meanwhile, electric vehicles demonstrate consistent performance with lower service frequency, reinforcing trust. And energy cost volatility further widens the divide. Fuel prices fluctuate with geopolitical events and supply constraints. Electricity, increasingly generated from diversified sources, offers greater price stability. Charging infrastructure continues expanding across urban and rural corridors. Home charging reduces dependence on external supply networks entirely. That autonomy translates into predictability. Predictability translates into value retention. And software-defined vehicles also introduce a different ownership psychology. Instead of aging out of relevance, they receive iterative improvements. Efficiency gains can be unlocked remotely. User interfaces evolve. Driver assistance systems refine over time. Hardware designed with headroom enables future capability. The vehicle purchased in 2026 does not remain frozen in 2026. It adapts. That adaptability contrasts sharply with combustion platforms that are mechanically fixed from production day forward. And environmental policy is another accelerating factor. Cities worldwide are tightening emissions standards. Some are restricting or taxing high-displacement vehicles. Corporate fleets are transitioning to electric to meet sustainability targets. As regulatory pressure increases, resale markets respond accordingly. Combustion SUVs may still function mechanically, but regulatory friction reduces desirability. Market demand softens and values adjust downward. And manufacturing philosophy also plays a critical role. Vertical integration allows rapid iteration. When software, battery design, motor production, and vehicle assembly are aligned under a unified engineering strategy, optimization happens holistically. Traditional automakers often separate engine development from digital infrastructure teams, leading to fragmented innovation cycles. Electric-first companies align hardware and software from inception, creating cohesive ecosystems rather than layered compromises. And durability metrics are shifting as well. Electric motors are engineered for high mileage with minimal degradation. Regenerative braking reduces mechanical wear. Thermal systems are optimized for efficiency rather than mitigating constant combustion heat stress. Even user experience contributes to longevity. Smooth torque delivery reduces drivetrain shock compared to gear-shifting transmissions subjected to abrupt load changes. And the perception of disposable engines is rooted not only in repair cost but in design intention. Some combustion powertrains are engineered to balance performance with regulatory compliance under tight constraints. That balance can shorten lifespan under real-world driving conditions. Electric systems, by contrast, are engineered around fewer constraints related to emissions complexity. Simplicity enhances endurance. And capital markets are also signaling the direction of value. Investment is flowing into battery research, charging networks, and energy storage integration. Infrastructure builds around electrification, reinforcing ecosystem strength. Vehicles designed to integrate with renewable energy grids gain strategic relevance. Combustion platforms lack that connectivity, limiting their role in future mobility frameworks. And consumer expectations continue evolving. Silence is now associated with refinement. Instant acceleration defines responsiveness. Minimal maintenance defines convenience. Digital interfaces define luxury. In that context, engine roar becomes less aspirational and more antiquated. Status shifts from mechanical spectacle to technological sophistication. And as 2026 unfolds, the contrast becomes increasingly visible in dealership inventories and resale listings. High-maintenance luxury SUVs remain on lots longer. Electric alternatives turn faster. Data-driven buyers are aligning decisions with future cost trajectories rather than past prestige narratives. What once symbolized dominance on the road now faces a recalibration of relevance. And the transformation underway is not about brand rivalry. It is about architecture. Mechanical complexity versus electrical simplicity. Reactive servicing versus predictive software monitoring. Fuel dependency versus energy flexibility. Finite engineering cycles versus continuous improvement models. The vehicles retaining value are those aligned with where infrastructure, regulation, and technology are heading, not where they have been. And the vehicles retaining value are those aligned with where infrastructure, regulation, and technology are heading, not where they have been. Alignment with the future is no longer optional. It is the defining characteristic of sustainable luxury. In a rapidly electrifying ecosystem, the automobile is no longer an isolated machine. It is a connected energy device, a rolling computer, an integrated node within a broader technological network. Vehicles designed around combustion engines were never engineered for that level of integration. And grid interaction is becoming a central theme in modern mobility. Electric vehicles are increasingly capable of intelligent charging, optimizing energy draw during off-peak hours, and adapting to grid demand. As renewable energy penetration rises, vehicles serve as dynamic storage assets, harmonizing with solar and wind generation patterns. Combustion SUVs cannot participate in that ecosystem. They consume fuel independently of grid intelligence, disconnected from the broader energy transformation shaping 2026. And battery technology continues advancing in density, durability, and cost efficiency. Manufacturing improvements reduce waste and streamline scalability. Structural battery integration enhances safety while lowering mass. As economies of scale expand, production efficiency compounds. This compounding effect drives down cost per mile over time. Combustion engines constrained by thermodynamic limits cannot experience similar exponential gains. Incremental refinements in fuel efficiency are marginal compared to the systemic efficiency leap provided by electrification, and consumer financing trends reflect this shift. Lenders analyze total cost of ownership when assessing residual values. Vehicles with predictable maintenance costs and stable depreciation curves secure more favorable financing structures. Electric platforms with reduced service complexity demonstrate stronger long-term value modeling. Conversely, luxury combustion SUVs with high projected repair exposure introduce volatility into financing equations. That volatility increases risk, influencing loan terms and resale assumptions. And digital ecosystems further amplify differentiation. Navigation systems integrate real-time charging availability. Route planning optimizes energy usage dynamically. User profiles synchronize seamlessly across vehicles. Remote diagnostics allow continuous performance monitoring. This connectivity extends beyond convenience. It reinforces reliability. Early detection of anomalies reduces downtime and protects asset longevity. Combustion platforms retrofitted with digital layers lack the native integration necessary to achieve this level of coherence. And manufacturing agility is another decisive factor. Electric-first production lines utilize large-scale casting, simplified wiring harnesses, and modular design. Reducing part count accelerates assembly and improves consistency. Quality control benefits from streamlined architecture. Traditional SUVs assembled from thousands of discrete engine components require complex calibration and testing sequences. Each layer of mechanical intricacy introduces variability. Simplification enhances precision. And material sustainability is reshaping purchasing priorities. Buyers increasingly evaluate carbon footprint across a vehicle's lifecycle. Electric drivetrains paired with renewable charging reduce operational emissions dramatically. Battery recycling programs and closed-loop material sourcing improve environmental accountability. Combustion engines dependent on fossil fuel extraction and combustion face structural sustainability limitations. In 2026, environmental transparency influences resale desirability as strongly as performance metrics once did. And autonomous driving capability is also redefining value retention. Advanced driver assistance systems rely on centralized computing power, sensor fusion, and rapid software iteration. Vehicles built with high-performance onboard processing can adapt as algorithms evolve. This adaptability extends usable lifespan. Platforms lacking robust computing headroom become technologically obsolete faster. Combustion SUVs not engineered with software-centric frameworks struggle to remain competitive in autonomy progression. And the ownership experience itself is transforming. Service visits become rare rather than routine. Updates deploy overnight instead of requiring dealership appointments. User interfaces evolve to meet changing expectations. Performance enhancements may be unlocked digitally. This redefinition of post-purchase engagement strengthens brand ecosystem loyalty and sustains residual strength. Mechanical vehicles requiring frequent physical intervention disrupt that seamless experience. And fleet adoption patterns provide additional evidence. Corporate mobility providers prioritize operating efficiency and predictable maintenance. Electric SUVs deliver lower energy costs per mile and reduce service downtime. Fleet data feeds back into resale markets, influencing broader perception. When high-mileage electric vehicles demonstrate durability with minimal degradation, confidence expands. Conversely, fleet operators divesting combustion SUVs due to escalating upkeep signal caution to private buyers. And urban planning initiatives reinforce the trend. Cities are redesigning infrastructure to accommodate electric charging corridors and restrict high-emission vehicles. Parking incentives, tax credits, and toll exemptions favor electrified platforms. Regulatory alignment with electrification creates compounding advantages for electric SUV ownership. Combustion vehicles encounter incremental friction that erodes convenience and economic appeal. And technological convergence accelerates the divide. Artificial intelligence optimizes battery health. Machine learning refines energy efficiency patterns. Cloud connectivity synchronizes global improvements. This convergence produces continuous enhancement rather than static performance. Combustion engineering limited by mechanical constraints cannot leverage digital scalability to the same degree. And the concept of disposability ultimately reflects architectural misalignment with the future. Engines engineered for a combustion-era face diminishing infrastructure support tightening regulation and escalating maintenance economics. Electric platforms align with renewable expansion digital ecosystems and software-defined innovation. That alignment sustains relevance. And in 2026, luxury is measured less by engine displacement and more by system intelligence. Less by exhaust acoustics and more by energy efficiency. Less by mechanical complexity and more by digital refinement. Vehicles that integrate seamlessly into evolving energy networks, regulatory landscapes, and software ecosystems retain strategic value. Those anchored to legacy combustion paradigms face accelerating depreciation as the broader mobility environment advances beyond the limits of internal combustion engineering. And vehicles that integrate seamlessly into evolving energy networks, regulatory landscapes, and software ecosystems retain strategic value. Those anchored to legacy combustion paradigms face accelerating depreciation as the broader mobility environment advances beyond the limits of internal combustion engineering. The pace of change is relentless and market expectations are evolving in tandem with technological progress. Consumers are no longer merely evaluating horsepower and luxury trims. They are analyzing efficiency, adaptability, and the total cost of ownership over the life of the vehicle. The era in which engine size alone defined prestige is over. Value is increasingly tied to a vehicle's ability to evolve, interact with energy infrastructure, and integrate advanced digital systems. And the rise of connected vehicle ecosystems exemplifies this shift. Modern electric SUVs communicate with charging stations, grid networks, and traffic management systems, optimizing energy usage and reducing unnecessary consumption. Vehicles participate in energy arbitrage, drawing electricity during off-peak periods, storing it, and in some cases even returning energy to the grid when needed. Combustion engines are incapable of engaging with these systems in any meaningful way. Their fuel dependency isolates them from the broader energy transition, leaving them stranded in a paradigm that prioritizes raw mechanical output over systemic efficiency. And battery longevity and performance are central to this evolution. Advanced chemistries combined with intelligent thermal management allow electric vehicles to maintain capacity over hundreds of thousands of miles. Predictive algorithms monitor degradation and optimize charging patterns to extend service life. Electric motors with their minimal moving components reduce mechanical wear exponentially compared to complex combustion engines that operate under high stress and heat. This engineering simplicity is not a compromise. It is a strategic design choice that drives reliability and reduces unexpected costs for owners. And software-defined performance further differentiates modern vehicles. Unlike mechanical systems that degrade over time, electric platforms can improve after purchase. Over-the-air updates refine energy efficiency, enhance driver assistance capabilities, and unlock new features, creating continuous value. In contrast, traditional combustion SUVs remain static, constrained by hardware limitations, and unable to evolve beyond the specifications determined at the factory. The ability to adapt digitally extends the relevance and desirability of electric vehicles, reinforcing long-term ownership value and brand trust. And maintenance economics are another critical differentiator. Combustion engines with thousands of moving parts are inherently prone to wear and failure. Turbochargers, timing chains, fuel injectors, and exhaust treatment systems all require meticulous maintenance to remain functional. Replacement parts are costly, labor-intensive, and often sourced from complex global supply chains. Electric drivetrains, in contrast, rely on a fraction of the components, reducing potential failure points and maintenance frequency. Regenerative braking systems decrease whereon mechanical brakes and thermal systems are engineered for efficiency rather than constant stress mitigation. Lower maintenance requirements translate directly into improved total cost of ownership, which has become a decisive factor for buyers in 2026. And regulatory pressures amplify this divergence. Urban centers and governments are introducing stricter emissions standards, low emission zones, and incentives for zero tailpipe vehicles. Combustion SUVs face increasing operational restrictions, higher taxes, and reduced resale appeal as a result. Electric vehicles designed with compliance and sustainability in mind gain strategic advantages in both urban and regulatory contexts. Owners of electric platforms experience fewer barriers, better incentives, and improved long-term investment security, reinforcing the notion that architecture aligned with future requirements retains value, while misaligned combustion vehicles depreciate rapidly. And consumer expectations have evolved beyond traditional notions of luxury. Quiet cabins, instant acceleration, intelligent energy, use seamless connectivity, and predictive safety systems define modern sophistication. These attributes are inherently tied to the architecture of electric platforms and integrated digital systems. Combustion vehicles reliant on mechanical sound and raw power for status struggle to meet the emerging criteria for luxury in 2026. Perceived value increasingly correlates with technological intelligence, rather than traditional sensory cues like engine roar or exhaust note. And fleet adoption patterns reinforce these trends. Commercial and corporate fleets prioritize efficiency, reliability, and predictable maintenance costs. Electric SUVs deliver lower operational expenses, extended lifecycle performance, and real-time diagnostics that allow proactive management. Data collected from high-mileage electric fleets demonstrates durability and efficiency, further increasing confidence in their residual value. In contrast, combustion SUVs with higher and less predictable repair costs become liabilities for fleet operators, which is reflected in secondary market pricing and general consumer perception. And manufacturing philosophy and vertical integration also contribute to resilience. Companies designing vehicles from the ground up as electric systems align battery architecture, software, and vehicle mechanics for maximal synergy. This alignment allows iterative improvements and rapid deployment of new technologies across product lines. Legacy combustion models developed under segmented engineering processes face inherent inefficiencies in scaling improvements, creating an asymmetry in innovation speed and reliability. And safety and structural engineering also favor electric vehicles. Integrated battery packs enhance chassis rigidity and lower centers of gravity, improving handling and crash performance. Simplified mechanical layouts reduce points of failure that can compromise safety over time. Continuous software monitoring enhances situational awareness, optimizing both passive and active safety features. In combustion SUVs, safety performance is tied to hardware integrity, which degrades with use and may require costly replacement or repair to maintain. And consumer finance models are increasingly reflecting these realities. Lenders and insurers are assessing risk based on durability, maintenance predictability, and residual value trends. Electric vehicles with simpler architectures and software-driven performance enhancements secure favorable financing terms and insurance premiums. High-maintenance combustion SUVs introduce volatility into these models, leading to higher costs of ownership and diminishing investment attractiveness. And ultimately, the shift in value perception reflects a fundamental redefinition of automotive luxury. It is no longer measured solely by mechanical prowess or traditional brand prestige. Instead, it is defined by adaptability, efficiency, software integration, sustainability, and long-term cost predictability. Luxury in 2026 is measured by the ability of a vehicle to evolve, connect, and perform reliably within an increasingly electrified digital and regulated mobility ecosystem. Combustion SUVs anchored in outdated paradigms face accelerating obsolescence, while forward-engineered electric platforms are positioned to retain relevance, maintain performance, and deliver consistent value over time.